Good afternoon, everybody. Good afternoon, Chair and Co-Chair, sir. What we will be talking about today is more about how we are basically using hardware, the sensors. We have been seeing a lot of presentations since morning where we are looking at maps, how they've been generated, but sensors are at the core of it all, where the data is being collected. How are we consuming this data? What is happening with the data, and how is the user interface being worked on in today's time is what this presentation is all about. We are not going into the hardware because hardware sensors everybody has. We have multiple sensors going around. Something that we have currently in our basket, and what I know for sure that NESAC actually has, is the one at the right here, which is a GNSS receiver, and what we are looking at the center here, which is a laser scanner and a robotic total station. What we will see is how are we bringing all of this together from a user interface standpoint, where we bridge the gap from field to finish workflows. Now, when I say field to finish, is that how is my field guy utilizing the data that is coming onto his controller, and how is that data being consumed back in the office by my processing guys? How are we bridging this field and office anomaly that basically comes up when the guys in the field have collected something, but the guys back in the office have no idea what has been done in the field, and there are certain times when you have to go and do the stuff again. We are mitigating how do we basically be more productive with whatever we have been talking about, say, for example, from the classification AI standpoint, from the hardware standpoint, and how do we bring all of this at one ecosystem platform. Now, one ecosystem does not mean that everything has to be one OEM-based solution, like Trimble is an OEM, but Trimble has the gamut of softwares where we are consuming data from all other different third parties, which can be any platform that you use, for example, to create your own maps and databases. But how am I processing this data and then pushing it back to my deliverable softwares? When we say on the field, what am I able to do? On the field with these GNSS receivers, today we are collecting positional information. It's just a single point, but what I do with this single point is that I basically can create an entire plan, an entire workflow right there in the field. And when this data goes back into the office, my guys don't have to go through where is a point, where is a line, where are we connecting these dots. These dots are already connected on the field. What you're looking at here is something that is coming from the hardware on the field in real time. When I use all of this, now how is this cloud computation being used in the background? We are basically taking everything from design. Say, for example, there is a design. Say, for example, there is a CAD file that I have. And this needs to go to the field for my guy to see how is he going to stake out the points on the field and then push that data back into the office, is all being handled in the cloud. Now, how am I utilizing the cloud is that we have these 5-6 different steps. Of that, I can use it in offline and I can use it in online mode. My guys back in the office use it in the online mode, whereas my guys back in the field use it in the offline mode, because they will download the information and then they will process the information, develop more data, and push it back to the office for processing. All of this connected workflow is what Trimble is basically looking at. We are not looking at hardware anymore. Hardware Trimble has. Trimble has a lot of hardware that basically works. There are many consumers here. We're talking total stations. We are talking everything that we have from LiDAR to GNSS equipments. But what do we do with this user interface is what the whole prospect is. How do we connect the field and office together, where we are mitigating, we are being more productive, and what we want to generate is generated in time. This is basically one of the slides for the hardware where we are looking at an SX12. This is where we bring 3 different technologies together. We are talking about EDM-based total stations, which is a single point acquisition. We are talking about imagery, so we are bringing photogrammetry into it. And then we are talking about laser scanning, which is LiDAR. All of this in one unit is where now the user interface comes in. And when I say user interface, a guy who has used a total station gets overwhelmed when he looks at a point cloud, because it's millions of points for him to look into. Whereas if he goes through the same workflow that he has been using today.
1 minute, please.
So that's absolutely impossible, but I'll try. So when we talk about these hardwares, what kind of applications are these hardwares working on? Everything that you see here, from boundary to power lines to utilities to infrastructure to tank inspections, one single unit does this. So I'm mitigating, taking lots of different sensors along with me in order to collect data for getting information out of these sites. One unit does all of this. And how am I using this? What am I generating on the field is something like this. So this is coming from the camera. This is what you see in the bottom is coming from the camera on the field. And I'm generating a scan right there. And from the scan, I can actually generate an inspection report in the field itself. Now, this is something that my guy who is a surveyor can basically give me input well in time before the data reaches back into the office, and my guys in the office then start developing these deliverables. What are we connecting is all of this hardware, then back in the office, goes and sits at one place. Sorry. All of this basically goes and sits in one place. Oh, we are missing a slide. Sorry. So the slides are not. Okay, I'll just finish this here. So all of these different data hardwares, which are not necessarily Trimble, it's all coming from different OEMs. We consume this in something called TBC. TBC is Trimble Business Center that consumes data from all of this and then starts developing results, which are CAD drawings for you, which are 3D models for you, which is working on the point clouds. And once this is generated, that's where you start pushing it to where the actual deliverable at the end has to be. So one ecosystem, taking data from all of these different sensors becomes one software for you to work into. Currently, we are going from UAV has Pix4D, then Total Station has OEM software, LiDAR has another software. We are going in multiple directions just to generate the same answer at the end of the day. But in order to have this all in one place is what Trimble is working on. And Trimble Business Center as a software is an answer to photogrammetry, is an answer to scanning, is an answer to GNSS, traverse, and topographic workflows. We have all of this in just one package.
Please conclude, please.
Yes, sir. So basically, since this is not going any further, oh yeah, there it is. So you see all this corridors, surface, machine. I'm concluding it, sir. Just 1 second. So what we do is we are bringing AI, we are bringing machine learning back into the software for you to generate those classifications, for you to generate those deliverables. But this AI does not replace the work of a guy who is, we were just listening to blue collar jobs, but the jobs are not going anywhere. We are just facilitating AI. So this is a bit more responsible way of using AI in the background. And this is what we have done for Meghalaya. So living root bridges, what was the application? This is the actual site. This is the laser scan coming in. They wanted to know the age of these trees. And in order to do that, the way to do that is by knowing the elevation of the trees and how long, how tall they have been. So this is the elevation graph created right there in the field. We have not yet gone back to the office to generate any reports. Reporting is what office does. But this is what you generate in the field itself. This is the point cloud with the image overlaid on it. So photogrammetry, laser scanning, results. And that's what the whole combination of mitigating things together is.